Imagine this. You're looking at a web page, a really simple form. It asks for a few basic measurements, length, diameter, weight, and then it poses an almost impossible question. From just those numbers, can you tell the exact age of a living creature?
So here it is. This is the form we're talking about. It's designed to figure out the age of an abalone, which is a kind of sea snail. You plug in a few physical details, you click that submit button, and
Bam! Just like that, an answer pops up. 11.5 years old. And that, right there, is where the real mystery kicks in. How on earth does an application, something with no pulse, no biology degree, solve this kind of riddle of the sea? I mean, it feels like magic, but it's not. Today, we're going to pull back that curtain. We're going inside the digital factory that actually builds this kind of intelligence. Because the secret isn't some single brilliant piece of code. Nope. It's a whole automated assembly line for creating and maintaining AI itself. Okay, so this whole blueprint, it has a formal name, the Machine Learning Software Development Lifecycle, or MLSDLC for short. Yeah, it's a bit of a mouthful, I know, but the idea behind it is what matters. It's all about having a repeatable, automated process that takes an idea from just a concept to a continuously improving, intelligent app. This is the engine behind our Abalone calculator.
so this right here, this is our map for the journey we're about to take. Think of it as the master blueprint for our AI factory. We're going to walk through this whole cycle piece by piece, and we'll keep coming back to this map as we put it all together. But first, who actually works in a factory like this? Well, it takes a village. You've got your data scientists, your ML engineers, security folks, a whole cross-functional team. But the most interesting piece of this puzzle is that group right in the center, the platform team. They aren't just another department. They're like the orchestra conductors, the glue that holds this entire complex operation together and makes it all work as one. All right, let's start our tour of the assembly line. Our first two stops are absolutely critical: build and test. This is where the idea becomes a real thing and where we make darn sure it actually works. First up is the build stage. Picture this as the very beginning of the assembly line. It's where all the raw materials, the source code, all that historical abalone data, and the core logic get fed into the system. And from there, the pipeline just automatically kicks into gear, crunching the data, training the model, and spitting out a polished, production-ready piece of AI. So now we've got this shiny new model. But you wouldn't just roll a brand new car onto the highway without testing the brakes, would you? Of course not. And that brings us to the next vital stop on our map, the test phase. Welcome to the test deployment stage. You can think of this as the AI's own personal crash test facility. We deploy the entire application into a safe, sandboxed replica of the real world. In here, automated scripts pretend to be thousands of curious users, clicking buttons, feeding it weird data, even trying to break it, all to make absolutely sure every single part works perfectly before a real person ever lays eyes on it. Okay, the model is built. The system is tested. We're feeling good. We're confident it works. Now, it's time for the main event, rolling it off that assembly line and out into the real world. Let's look back at our map. We're now heading into the final phases of this first run, deploy and maintain. This is the big moment. This is when our Abalone calculator goes from being a tested prototype to a live public application that anyone can use. So what's really the difference between that test environment and the real thing? Well, it's kind of like the difference between a go-kart and a Formula One race car. The test environment, that's the go-kart. It uses minimal, cheap resources just to prove the thing works. But production? Oh, that's the F1 car. It's built with powerful, scalable engines for crazy high performance, and it's packed with sensors for full logging and monitoring. And this is that final deployment stage in our pipeline. Now, it might look a little simpler, but don't let that fool you. We're not deploying the go-kart anymore. This is us rolling out the Formula One car, a fully optimized, elastic system that's ready to handle thousands of users, scale up or down on demand, and log every single move for the future. So our factory built and launched a working AI app. Job done, case closed, right? Well, not quite. What happens when the world changes?
Because what makes a system truly intelligent isn't just that it works, but that it can learn. This quote right here gets to the absolute heart of machine learning. A model that was trained on data from, say, the 1990s might not be so accurate today. New abalone surveys happen. New data gets collected. So how do we make sure our model doesn't become a fossil itself?
The answer is this brilliant idea called continuous training, or CT, and it's a completely automated loop. It's simple, really. First, a trigger. Brand new abalone survey data shows up. Second, a process. That new data is instantly cleaned up and prepared. And third, a relaunch. The entire AI factory we just walked through ticks off all over again. A new, smarter model is born, completely automatically.
And this simple-looking workflow is the secret switch that makes it all happen. You can think of it as the system's eye. It is constantly watching a storage location, and the second new data appears, bam! It triggers the entire factory to start a whole new production run. It's automation at its most elegant.
So let's zoom out and take a look at the whole picture we've just put together. All these different stages aren't just one-off events. They're all interconnected gears in a much, much larger machine. And here it is, the full AI factory in all its glory. What we've really built isn't a straight line that has a start and a finish. It's a perpetual loop, a cycle of creation, testing, and evolution. Whether it's triggered by a developer pushing new code or by brand new data appearing, it's a living system designed for constant self-improvement. It makes sure our application doesn't just start smart, it stays smart. So we have this incredible pipeline that makes sure our model is built right and it can even learn from new data. But what about those quiet times between the updates? How do we know the world hasn't shifted in some subtle way that's making our once brilliant models slowly, quietly wrong? The pipeline ensures the model is built right, but how do we know it stays right? Well, that's a story for another time.
Hurry, hurry!